Okay, so I'm going to have a review problem here of empirical formulas. If you remember how to do this, because this was just yesterday's lesson, you can skip this part, but I'm just kind of reviewing it. So you have a compound, you want to find the empirical formula. The first thing you want to do is assume 100 grams of the compound, which means you have 40 grams of carbon, 6.7 grams of hydrogen, and it says the rest is oxygen. Well, if it's a percentage, all percents add to 100. So the oxygen would be 100 minus 40 minus 6.7, so 53.3 grams of oxygen. Okay? So first thing you're going to do in an empirical formula is you always change from grams into moles, recognizing that no element in an empirical formula is ever diatomic. That means oxygen is O and hydrogen is H, and you're not doubling up the masses here. Divide this out and you get 3.33 moles of carbon, 6.7 moles of hydrogen, and 3.33 moles of oxygen. I think it's pretty obvious that the ratio right here is 2 to 1 hydrogen to oxygen, and the ratio here is also 2 hydrogens to 1 carbon. So that means your empirical formula is C1H2O. That's your empirical formula. You don't have to write the ones, you do have to write the 2. That means the smallest whole number ratio of this compound is 1 to 2 to 1. Doesn't mean that is the correct ratio for the real chemical, because a lot of times, particularly organic compounds, they are multiples of that, and that's what we're going to talk about today. A molecular formula is the last step in determining what exactly something is. Empirical formulas are the smallest whole number ratio. The molecular formula is the actual ratio, and it is a whole number multiple of the empirical formula based on molar mass, and that is kind of key. All right, so it's the actual ratio. The last problem, I had CH2O, 1 to 2 to 1. Well, there is a compound, C3H6O3. All right, the ratio is still 1 to 2 to 1, but it's 3 times as heavy. It's a multiple of 3. This stuff weighs 12 plus 2 is 14. This weighs 30 grams. This stuff, guess what, weighs 90 grams. So it's based on molar mass, how you figure out what the multiple is. 90 divided by 30 is multiplied by 3. Okay, so we'll give you an example. Water has an empirical formula of H2O. It weighs 18. The molecular formula is the same formula, so the multiple can be 1. It doesn't have to be a number other than 1. So it can be 1, and it's 18. CH2O, this is the one I just showed you, 1 to 2 to 1. It weighs 30. This is glucose, or dextrose, depending on which sugar you're looking at. But the ratio is still 1 to 2 to 1. It just weighs 180. And if you take 180, you divide by 30, you get a ratio of 6. That's where that multiple comes from. If I add this guy up, it weighs 43. From here to here, I think you can see it multiplied by 5. Well, the way you would know that is 215 divided by 43 is, guess what? 5. That's how you determine the multiple to go from one to the other. That's where it comes from. It's based on molar mass. So, the relationship between the masses of an empirical formula and a molecular formula is the mass of an empirical formula times some number equals the mass of the molecular formula. Or, if you take the mass of the molecular divided by the mass of the empirical, you're going to get the multiple you want. Okay, and it can be 1. All you have to do is take the empirical formula, multiply all the subscripts by that number, and that tells you the molecular formula. So empirical formula of an oxide of phosphorus is P2O5. Okay, so that's the smallest ratio, 2 to 5. I think we even had that in one of the movies. Oops. 2 to 5. Now, the molecular formula has a molar mass of 284. So the molar mass of the molecular formula divided by the molar mass of the empirical formula is how you figure this out. Well, 284 was given to you. What I need to do is add this guy up. So 31 times 2 plus 5 times 16 is going to be, that's 80, plus 62 is 142. This divides out nicely to a ratio of 2. That means the molecular formula is 2 times P2O5 or P4O10. That's the molecular formula. Still a ratio of 2 to 5, but it weighs twice as much based on molar masses. Oops, I'll put that in there. Okay, so let's do one more. So 85.7% carbon. So now we need to find the empirical formula. So we're going back. And a lot of times these build on each other like that. So we're going to assume 100 grams. You got 85.7 grams of carbon and 14.3 grams of hydrogen. 1 mole of hydrogen is 1 gram. So just like before, that hasn't changed. Carbon, 1 mole of carbon is 12 grams. Do that on my calculator because I don't know the answer to that one off the top of my head. And I get 7.14 moles of carbon. To find an empirical formula, you take the moles of one element and divide by the smaller number of moles, smallest number of moles. I get a ratio of 2 to 1 hydrogen to carbon. So my empirical formula is CH2. Okay, so I had to go through and do all that process that we've been doing all along and find the CH2 part. Now I'm going to erase the ink on the screen and I'm going to write down CH2 was the empirical formula. Okay, it, meaning this guy, has a molar mass of 126. The molecular formula is a multiple of CH2 times some number. And I need to figure out what that number is. Well, 126 is how much the molecular formula weighs. This one is 12 plus 2. That's 14. So let's see what 126. 14 is. That would be 9. So I'm going to take CH2 and I'm going to multiply by 9. C9H18. Still the same ratio, 1 to 2, but it's 9 times heavier because of molar mass.